Welcome to the podcast on solving equations with a single rational exponent. Before we get into this, I want to remind you of a couple of rules from algebra that are going to be very important in understanding this. First off, solving equations with a single rational exponent, that's like this equation here in example 1. That 3 over 2 is called a rational or fractional exponent. There's only one of them. This is the procedure that you use when your original equation looks something like this. Okay, first rule I want you to recall from algebra is that if you take an exponential like x to the a and raise it to the power b, the result is x to the ab. So suppose I had an expression with a rational exponent like x to the 2/3. And suppose that I raise it to the power that I get when I flip 2/3 over to get 3/2. Then according to my rule, I would get, as a result, x to the 2/3 times 3/2. Well, the 3 would cancel the 3, those become 1s. The 2 would cancel the 2, those become 1s. So we end up with just x to the 1, or x. In other words, by taking a rational exponent and raising it to the reciprocal power, we get rid of the exponent. Now, the second thing I want to bring up is the definition of x to the m over n power. And x to the m over n power means, by definition, that's what the equal with a d above means. It means this is equal and this is the definition. It's x to the 1 over n to the m if x to the 1 over n exists. And we're going to limit our x's in this case to real numbers, so if that's a negative number to the 1 over an even exponent, then you're trying to take an even root of a negative number and you won't be able to do that. So, according to this definition, what would be the meaning of negative 27 to the 2/3 power? Well, it would be negative 27 to the 1/3 power squared. That is, the bottom number, the n, is the root, so I say the 1/3 power, and the top number is the power, so the power 2. Well, if I cube negative 3, I get negative 27. So negative 27 to the 1/3 is just negative 3 squared, which is 9. So negative 20/3 to the 2/3 power, take the cube root, and then square it. In general, in x to the a over b, the bottom number is the root, the top number is the power. Think of it this way. Roots grow from below, so the root is on the bottom. Power comes from on high, so the power is on the top. Okay, with all that in mind, let's try the first problem. Now, if this was just 2x minus 3, this wouldn't be a problem. We could easily solve that for x. So what we need to do is get rid of that rational exponent. So I'll use the technique that we saw above. I'll take 2x minus 3 to the 3/2 and raise that to the 2/3. And I'll take 8 and raise that to the 2/3. And on this side, I get 2x minus 3 to the 1, which is just 2x minus 3. On this side, I get 8 to the 1/3 squared, which is 2 squared, which is 4. So I've got 2x minus 3 equals 4, 2x equals 7, x is equal to 7/2. Now, when you're doing this sort of thing, you're messing with the powers, you're changing the degrees. So when that happens, that's the time when extraneous roots can come into play. So what we want to do next is we want to make sure that 7/2 actually works as an answer. So what I'm going to do is try it into the original problem. I'll say 2 empty hole minus 3 to the 3/2 and see what I get. Into the empty hole will go 7/2. The 2 cancels the 2. So now I have 7 minus 3, or 4, to the 3/2, which is 4 to the 1/2 cubed. Well, 4 to the 1/2 means the square root of 4. The square root of 4 is 2, so that's 2 cubed, which is 8. Well, it was supposed to be 8, and so that answer does check. But a word of caution. if I had made that a negative 8 in the original problem instead of 8, it turns out that I would have still gotten x to the 7 halves. When I plugged it in, I would still get 8. 8 is not the same as negative 8. So what I'm telling you is, if this original problem had had a negative 8 here, you would have still gotten this answer, but it would not have checked. And when it didn't check, you'd have to scratch it out and say, no solution. Okay, let's move on. The next problem looks the same, so let's try the same technique. I want to get rid of the 2/3 power, so I flip it over, and I take my x minus 1 to the 2/3 and I raise it to the 3 halves, but I can't do that unless I also raise the 16 to the 3 halves. Well, on this side, the 2/3 times the 3 halves gives me 1, so I just get x minus 1. On the other side, I have 16 to the 1 half, which is 4, cubed, which is 64. So my final answer is 65. I'll leave you to plug that in and check it. But it does work. Now, let me show you a second way to work this problem, and I'm calling it the better way. And I think you'll see why as soon as we finish this. If I start off with the same, solve x minus 1 to the 2/3 equals 16, I can rewrite this in the form, remember back when we were doing the square root property, if we could get an equation in the form m squared equals k, then we could write m was positive or negative the square root of k. I can write this as something squared. I can write this as x minus 1 to the 1/3 squared, because when I multiply the 2 times the 1/3, I get the 2/3 power. So those are the same. Now I didn't do anything different to the left side. I just wrote it in a different form. That's why I'm not doing anything on the right side. I did not change the left side. X minus 1 to the 1/3 squared is exactly the same as x minus 1 to the 2/3. But now it's in the form m squared equal k, where m is x minus 1 to the 1/3. So I can write that x minus 1 to the 1/3 is equal to positive or negative the square root of 16, which is positive or negative 4. Now, suppose I want to solve this. I could cube both sides. X minus 1 to the 1/3 cubed is equal to positive or negative 4, either positive 4 or negative 4 cubed. And on this side, 3 times a third is 1, so that's just x minus 1 to the 1. And on this side, when you cube a 4, you get 64. So you're either going to get positive 64 or you're going to get negative 64, which means that x is going to be 1 plus or minus 64. Well, 1 plus 64 gives us the answer 65 that we had over there. 1 minus 64 gives us the answer negative 63 that we did not get over here. There were actually two answers. It turns out that both of these check when you put them back in the original equation. Now, there's two ways to handle that. And the key is this top number. When that top number is even, and you're going to this step here where you remove this exponent and you get a number on the other side, if the top number is an even number, you could just say, instead of x minus 1 equals 64, you could say x minus 1 is positive or negative 64, and that would allow you to use this method and still get both answers. But the best way to do this is to write this as m squared equals k and use your old square root property to solve it. But I don't care which way you do it, but don't leave out the negative 64, and remember, you get the negative when the top number is even. We wouldn't have gotten it here. And that concludes the podcast on solving equations with a single rational exponent.